Hey class, let's jump in and look at the second part of regular expressions in our journey through the remainder of chapter 6 and then some select parts of chapter 7. First, here's the demo, and it's a combo demo and lab this week. So I'll step through the demonstration parts of this and then point out the lab portions where you'll have to complete code for the now you try segments. There'll be cells in there for you to specifically edit. All right, let's first start with regular expression methods. And here's a little bit more about the .match function. You know, we learned last week that .match will return a Boolean about whether a match was found or not. However, the match function here, it actually returns a little bit more information. And if the pattern that we're trying to match, if the regular expression pattern happens to have any grouping that's defined by parentheses, well then the match method will actually return individual match data for each group. So let's say that we have this expression here where we've got three groups in some regular expression, you know, an A plus, a B plus, and a C plus. What match will do is return specific values for each of these groups, numbered sequentially starting at 1, and it'll let you know, well, what exactly did match with this group? You know, what portion of a target string actually matched for this group, and then this group, and then this group. And that's kind of cool. And then, by the way, we delineate those with M, you know, presuming M is what gets returned from the match function. M.group is what we would use. And then sub 0 will return the entire match. Sub 1 returns the first group's match, sub 2 and sub 3, etc. So let's take a look at this pattern here. Okay, now I'm sharing the whiteboard and we see the regular expression here. And let's just review what these mean. Of course, the plus sign always means 1 or more. The asterisk means 0 or more. And the question mark means 0 or 1. So because we get A plus in a group, B plus in a group, and C plus in a group, you know, these are logical groupings. We would see then that, you know, what would match here would be any number of A's, provided there's at least one, and at least one B and at least one C. So A, B, C would match. A, B, B, C, C would match. What would not match would be B, B, C, because here we definitely need at least one A. Now, we could easily make this regular expression this, and it would still fill the bill. But if we do group here, we do get some more functionality, particularly being able to see, well, if we give it a candidate pattern and we get some matching, well, we get to see exactly which portions were met. So in this case, you know, we could go either way, but if we were to code the regular expression in this format, we would get a little bit more information and functionality. Okay, I'm gonna head back to the other screen. All right, here we are. So this pattern is our variable that's going to store the string that contains the pattern. And then, of course, we can use that wherever we want. Now, match will return, in this case, sort of a group object. And we'll be able then to index this group object with a simple index. And that object is actually going to have its own method called group. So we'll make the result that we get returned here M, all right, and then we'll just do a for loop here that's going to just go until the very last grouping number. And this last index version right here, this last index, I should say method, will actually return the index number of the last match. So in this case, you know, we'll get a 0, 1, 2, and a 3. This is going to go up to a 3. So here we would then go to a +1, so we get all 4 of those together. So for ion range, and this evaluates to a 4. and that'll give us all four of the values. And then here we just print out the index, but then the important part here is m.group sub I. And again, m subgroup sub 0 gives us the entire string that we did match. Sub 1 lets us know, well, what of the first group of A plus was matched. Second, what was B plus, and C, what was, and third, what was the C plus match. Now you can see here in this pattern that we have a couple of trailing E's, and since we're not demanding that the pattern stop at C, we can have some follow-on straggler characters here, and it would still result in a match. So here, when we do parse this, we would see that the ABCCC is the part that was actually matching. So that's what we get here when we output group 0. We get the whole match. And then we would get the first group. So what portion of ABCCC matched the A plus, and it's the A. And then what portion of the ABCCC matched the B plus, and that's just the B. And then finally the CCC. And if we remember right, we could put an asterisk there. And oops, let me go back and run all of these. There we go. If we run the asterisk there, well, we get the problem here of, well, there were just simply no matches, and we get that error. Here then, just for grins, I'm printing out a separate line of group 2, which is going to be the B's, and a separate line of the group 3s for the C's. So that's all pretty straightforward. Your turn to try here for this lab is to create a regular expression. This time we want to use compile. Remember that we can use re.compile to compile that regular expression into a regular expression object. And then we can just reuse that object over and over. So your pattern here is matching one or more X characters followed by any number of any characters, and then followed by one or more Z characters. So create those in groups and output the pattern then for each group. Now then, here are some samples, and then use these for your actual testing. Use these in a list. And you'll see here, when you try these, that you'll get various matches. Some of these won't match, and you'll need to make sure you understand why those won't match. So here is your cell to code that part, couple lines of code, and then you should get results like this when you do that very first, or the second one here, Xanadu's, this line here. When you run that through, you'll get results that look like this. All right, so that is re.match. Now, the next thing that we need to talk about, we covered here in the book in section 6.9, and this is using re.search in order to search for patterns. Now, the difference between match and search is that match will try and attempt to match an entire string. But if we don't care about matching an entire string, in and of itself, for example, if we're trying to match a phone number or a social security number format, those have to be an entire string, take it or leave it. But let's say we want to just search a subset of the string. Maybe we have brought in a whole story and stored it in a string, and we want to see what matches there might be anywhere in that string. Well, then we would use .search. So here's an example of searching for a pattern in any kind of a target string that contains 2 or more digits. So let's look at this code here. There's the regular expression, and then let's break this up then on the whiteboard. here's that regular expression, and let's bust it apart now. Of course, the preceding R just tells us it's a regular expression. We've got the single quotes, so really all we care about is this portion right here. And we can see that there's two separate tokens in this. There's a \D, and then inside braces, there's a 2 comma. So just to review what these are from last week's work on regular expressions, the \D will match any digit. And then if we have a token and then we've got a token right behind it that's in these braces, well, this token then applies directly to the preceding token. And this tells us how many times to expect that to be repeated. So in this case, these values here are min and max. And in the absence of a max value, this ends up being saying a minimum of 2. So a minimum of 2 times for any digit. So this would match 44. This would also match 304 because that's any 2 digits, but it's a minimum of 2, and this keeps on going to the 4 part. And so this would match since we have no max specified. Back to our code now. Here we have a target, and that is just a string with some numbers in it. And search will actually just return the first instance that we find. We'll search later for more, but for right now, .search it just returns the first instance of a location that was successful. So here we will expect to see when we run this 1000 to appear because that's going to be the first instance of 2 or more digits. All right, so there we use re.search, and then once again, we assign this to a search return object, M. And because we're using this object, well, it's going to give us access to m.group. And if we do m.group sub 0, that is the entire match. And there's also a method that's called span, m.span, and it'll actually give us the location of the match within this string. So we run this and we see, all right, re.search, it takes, first of all, the pattern as an argument. The next required argument is target. And then the final argument is going to be any flags that we want to put in. Again, this one will output the entire match, and then this one will output the position within the string of that match. So we run this, and you see here we get the results of 1000, and then also we get this tuple showing, okay, well, what is the beginning character index in this string, and what is the end? So here, if we go to this character and start counting these characters, well, we see that the capital F is 1, 2, 3, 4. I'm sorry, 0. 0, 1, 2, 3, 4. So the first one is at position 4, and then we get 0, 0, 0. So that's positions 4, 5, 6, and 7. And that's what's output here. This tuple is standard. The ending argument is not inclusive. So you will have a chance to try your coding here. Here's a target, 99 bottles of beer on the wall. And you'll need to search for 2 things. First, do a code block there, just searching for those first 2 digits. Then do another code block, trying to find, well, where is the word beer in this string? Okay, let's look at how we can search for patterns and return all of the pattern matches and not just the first instance. re.search returns just the first instance. We can use find all, though, to find all of the matches in a target string. So we can modify our code above just a little bit to use find all here. We use the same arguments, pattern, target, and flags. And we're going to use the same target. We're going to use the same pattern. Again, we're going to compile this into a regular expression object. And here we're just going to use find all. Now, find all is different from search in that find all returns a Python list. re.search returns a Python search object, and those are vastly different. So here, if we do find matches, they'll just be added to this list, appended to it. So that's why we have a typical for loop here. Again, a for loop that is not using an index, but instead just pulling the data. And you can see here when we run this that we get 1,000 and then we get 999, since those are both of the instances where we would have a match, okay? Now I'm challenging you now to take this to the next level. Let's suppose that the digits that we're trying to match here, the numbers we're trying to match, perhaps they've got the American comma separator in it that separates the thousands digits. Or maybe there is a decimal in it and it has some decimal places. Well, we can just adjust the pattern accordingly. Rather than just \d, we can really make it accept either one of these. And then let's bust this out over on the whiteboard. Okay, here's our regular expression, and we can see kind of what the tokens are in this. So the \d, of course, will match any digit. So that means that our match string, match sequence here has got to start with a digit. It must have any digit at all. It can be 0, can be 9, any of them. So it must start with a digit. So that's this first sequence here. Now there's another sequence here that is bound by a character set. And to recall from last week, a character set means, okay, the next digit can be any of these characters. So that's what this will say. The next digit, any of these. So that will then, of course, support the comma. It'll support a decimal spot, a decimal place, and then continuing to support any digit. Now we could probably refine this better to demand, if there is a comma, to demand 3 characters after that, 3 digits after that. But I'm just going simple here for this this demo. And then finally we have an asterisk, which means, okay, 0 or more of the preceding token. So 0 or more of these. And those two stay bound together. So let's next take a look at some of the matches for these. Okay, we are using compile to compile this regular expression phrase. Here is the target, and you'll notice that I've converted it to a thousands format, and then the 999 has got a decimal in it. And then here, sure enough, we run this and we get the results where it found these all successfully. Interestingly, you know, I mentioned that we should modify this a little bit. Maybe that'll be an exercise for you all, because even this this string here, 92, 4, even that matches as we saw there. So that'd be an exercise for you all to figure that out. Now, for the portion of this lab there where you try this, we want to try to match now all instances of any word that starts with a Z, and that can be either a capital Z or a lowercase z. And the word has got to have 4 or more letters in length. So this will easily start with a character set, either Z or Z. And then if it's 4 or more, that means a minimum of 4. And we would put those arguments in braces, and that would start to form our regular expression there. So good luck on this cell right here. Should be just a couple lines of code. Now, find all behaves a little bit differently if we're dealing with groups. Okay, so if we've got the grouping in our regular expression pattern with parentheses, group, 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 find all is going to give some unusual output. And that's just because of the way that it is crafted. It's actually going to give you results like this. So let's take a look at this code here. Here's our regular expression that we're going to compile. And in this case, this is it's any number in the American system, which will have comma separators, and it'll have decimal points if there is a decimal component. And when we run this, we see, that, okay, there's a couple of groups in here. Here's one group that is bound together by a set of parentheses. And then here's another group that's bound together by a set of parentheses. And we bind them together in a group because that entire group then has to be repeated 0 or more times with the asterisk, and then it's repeated either 0 or 1 time with that question mark. So when we run this, though, we see that we get a list returned in find all, but we don't get what we expected in the list. Instead, we get a match for just the second group here, and we get a match for the third group. And that's it. So rather than the matches being, a list of where all the matches were, instead it's matching and giving a report of just what group matches there are. And that's a problem because we want our bona fide matches here. So the way we do that is all you do is you put parentheses around the entire regular expression like this. So we have a group within a group almost. The internal groups stay the same. We're just going to group the entire thing together. And then we get, I'm giving you a list here. Our target string has got a bunch of these in it, a bunch of good values, just separated by spaces. We could, we could put as many spaces in here. Oops, not that. We could put as many spaces in here as we want, and it's going to ignore all those because we're looking just at the values. All right, and then remembering that find all will return a Python list. Here we're just going to print out those values. Now, what's also interesting is that since the whole thing is grouped together, then all we're going to do is output the sub-zero component. So here, printing val sub-zero is sort of in and of itself a list within a list, and that's going to give us the exact list of arguments, of matches. So your challenge for here, this little segment is, well, let's try and generate a regular expression that'll accept a phone number. And a proper match will be a phone number with the full format, including the area code, or just the local number without the area code, just the 7 digits. So if this is our target string, we would see that, yep, all of these here would match, and then we would see that output there in the after the cell. So give that a shot and see what you can come up with. Now, in our next section, we want to look for repeated strings, repeated patterns. Maybe it was a mistake when we typed up the string, or maybe we want to identify if there are some repeated words here that we can go and like correct it. So here's an example. Our target pattern, our target string here is just the cow jumped over the moon. So we've got an instance where we are repeating the word cow twice. We're repeating the word the twice. Maybe there was an error in bringing this string in, or maybe there was just an error typing it. Now, what we can do for finding repeated words is we can use the special escape sequence of \1. And this will be our code for repetition. \1, make sure that it's not an L. Ones and L's look very close, but this is definitely a \1. So our code that we would create our regular expression for here is, first of all, we would group together \W, if we remember that escape sequence, that's going to give us all alphanumeric characters plus the underscore. So that's saying any of those alphanumeric characters can be repeated one or more times, but then provided there's a space, and then the \1 says, and if it's all repeated again, whatever token was just there, if that gets repeated again. So anything before this, if it gets repeated. So we see here that our pattern is going to be this here, our target, and we will use the same .search method. Notice we're going back to search and not in find all. And we've got our pattern, our target, our flags as arguments. And then you guessed it, we will print out the result there, m.group. We'll also report the location of it with m.span. And we see here that we get cow detected as a repeated word. Now, it only did the first instance of the repeated word, and that's because we're using .search. Let's convert this now to find all, and that'll give us an idea of other repeated patterns. Here, pardon me, my vanity light went out, so I needed to plug that back in. We're saying that find all then will give us all of the repeated words, not just the first instance. So let's look at how we alter the code here using find all. Now, in this case, for flags, I am going to go ahead and throw in a flag here. If we remember re.I says ignore the case. So we're going to tell it, okay, it doesn't matter if the word this, for example, is capitalized or not. It is going to ignore it and then do a match just based on the lowercase versions of those. So our target now says this, cow, jumped over the moon. And we have 3 instances of a repeated word that might end up being a mistake. So we can identify those. So find all, we will put the pattern in here. I didn't create a pattern, I maybe should have. And then our target and flags. And again, find all returns a Python list. So we just have to iterate through the list and print out the results. And sure enough, we get the words that were repeated there, this, cow, and the. So the now you try is just a quick regurgitation of that, so to speak. There is a target string here. Now is the time to get an A in this class. So we've got a couple repeated patterns there, and create the code necessary to detect those. And your Python list should list those 2 things. Now is the time and in this. And then make sure that you ignore case so that the capital now also matches with the lowercase now. All right, well, let's look next at how can we replace text, and we can use .sub to substitute text. So here's a simple example. This is our target expression here. Zach and Zane will do the dishes at the zoo. So what we want to do here is just simply replace zoo with observatory. So here's a regular expression pattern for zoo. It'll accept an upper or lowercase letter. And zoo must be, Z-O-O. We could even change this O to put a 2 there to be a little bit more formal, showing that O's got to repeat twice. And we do want to substitute in the word observatory. So the re.sub method, you guessed it, it takes 3 arguments now. The pattern, what we're going to substitute, and then what the target string is that we're going to look at. So when we run this, we get the result here that Zach and Zane will do the dishes at the observatory. We got that successfully repeated. Now then another pattern that we can use would be, well, let's go back to that example with repeated words. Let's go back and fix that now because we want to omit those repeated words. So we'll use that exact same pattern here. where that matches the backslash W plus represents one or more alpha numeric characters in a group. And then the escape sequence \1 will match repetitions repetitions of the previous pattern. Now that's the pattern. To substitute in, well, we can just substitute in the repeated portion of it. And that is going to just simply substitute in. It's actually going to take out the second instance, and it's just going to substitute in the first instance. So let's see this in action. Here's our target again. This, cow jumped over the moon with those repeated words. So our regular expression pattern is this right here. What we're going to substitute is this right here. We're going to take out, the grouping of the \W characters followed by a space and just simply return the repeated value. And we'll do the result here, and .sub will return a modified string. When we run that, we see, okay, well, this now gets completely cleaned up, and the string now reads better with this cow jumped over the moon. Pretty straightforward there. All right, so now you've got a little segment here to try and code. We'll go back to that previous now is the time to get an A in this class. Take that string and let's clean that up so we get just this. Now is the time to get an A in this class. So here is your target output here. All right, I wanted to have us also look at section 7.3 in the book, and that's greedy versus non-greedy matching. And here's what those definitions are. So greedy says, okay, given a choice, I'm going to match as many characters as I can. Non-greedy says, okay, given a choice, I'm going to match as few characters as I can. So let's take a look at what this could possibly mean. I'm going to shift over now to the whiteboard. Okay, here on the whiteboard, I've got this sketched out. Here is our the string that we want to take a look at, our target string here. And we see that it's got like some HTML tags on it. And we want to match a pattern. Here is the pattern circled in blue here, and let's parse that. We can easily break out these tokens into 1, 2, 3 areas. So here's the first one. Here's the second one. Here's the third one. And this starts by saying, okay, the first character has got to be a left angle bracket. Then that will be followed by any number, including 0. So 0 or more of any character whatsoever. And then followed by a closing angle bracket, this one here. Now, what greedy and non-greedy behavior means for us is, well, what exactly is going to be matched? Now, greedy, again, let's write this down. Greedy is going to, of course, be greedy, and we want to do more and more because I'm greedy. So this will match more characters, and non-greedy will match fewer. So let's take a look in this case. The greedy, or let's start with non-greedy. The non-greedy would, of course, match this first angle bracket, and then it would match H1 here as, 1 or more of any character. I'm sorry, 0 or more of any character. And then we have this closing brace. So our pattern has been matched, okay? So that's what non-greedy would match, just that very first tag of this. Now, what a greedy solution would do here is it would say, okay, wait a minute. This character right here, even though it matches in part 3 here, it's still just a character. And if we treat it like just any old character and not necessarily the delimiting or the ending token in our regular expression, well, then we can continue to match all of these characters here too, and finally end at this last angle bracket. So that's what a greedy solution will do. It's going to match all of that and say, okay, this entire string, including the two sets of angle brackets, will all be matched. So I hope that helps to describe just what would actually be matched with a greedy and a non-greedy solution. And then we'll take a look at how we delineate these when we look at the code. Okay, here's two code snippets that will demo the greedy and non-greedy. So this first one here is the greedy. And this is just going to be a normal compile. Greedy is the normal default behavior for pattern matching. It's going to automatically be greedy. So if we compile the regular expression here, here's our target. Re.match is going to return a result. We can print that result with result.group, and it's going to then give us the entire thing. I added some code in here showing, well, what would happen if you just print out, this resulting object? And you see that match always returns a match object rather than just a string. And you can see here that when we print out the result, we get the data type first. This is a match object. We get some extra information about span that we could get with result.span. We get some extra information about what was actually matched that we could get with result.match. So pretty straightforward for greedy. It's just the default behavior. Let's change it though. Let's go to non-greedy. And the way we tell the pattern matcher to go into non-greedy mode is that we're going to use the question mark. This will be another use of the question mark. We used it before along with the plus sign and the asterisk to generate 0 or 1 instances of the previous token. Here though, if it's immediately right after the asterisk or plus sign or even another question mark, so it'd be a 2-character combination of asterisk question mark, those form their own sequence. And if we ever do that, well, then the pattern matching goes into non-greedy mode, and it's going to then try and match fewer instances. So here we added this simple question mark after the dot asterisk. So repeat any character, but do it in non-greedy mode. And we see here that when we run this, we get this the result of just that first HTML tag that matched here. So you'll have some fun here with this one. Here is a target, and let's do the greedy and the non-greedy versions of matching up this target. We can see here that if we have double square brackets to open a pattern, and if we have double brackets, square brackets to close a pattern, that there could be multiple possibilities here because of the greedy and non-greedy behavior. All right, and then just the very last thing that we wanted to look at in this chapter is going to be the re.split method. .split is going to shift gears a tiny bit. So far we have been trying to match the target. Our patterns will make every attempt they can to match a target string. But let's shift gears here a little bit. We're going to use .split to take a string, a candidate string, and break it into tokens. Break it into tokens that match. The only difference here is that we're not matching the token itself. We're going to try and match the separator, or in other words, what is being used to separate these valid tokens. So in this case, let's suppose that we have this string here. We can see that, okay, there's 4 names here. They all start with J, by the way. And the separators, though, for those tokens are going to be a 3-character combination of a space, a dash, and a space. So that's our separator. So in this case, we create a regular expression pattern based on that separator. And here it is right here. And matter of fact, we call it not pattern, but we actually call it separator with that space dash space. All right, then here is our target string, our candidate string. We could call it str, we could call it target. Let's call it target. And then here, re.split is going to take two arguments, just what is the pattern we're trying to match as the separator, and what is the target string that we're looking to break tokens out of. And this is going to return a Python list. And that list will just be simply all of the tokens that were parsed from this string with all of the separators removed. So here, printing this list here, you can see that we get, okay, in list notation, we get the four names that we were hoping to extract. So that's pretty straightforward. Now for your now you try, I want to change it up a little bit to where now the separators are slightly more complicated. The separators will have that vertical line in it, but a separator will have these rules. Okay, it's going to start with any number of spaces. The next token would be followed by that vertical line. And then the third token in the regular expression would be followed by any number of spaces. So you can see here that, if we made this separator, that regular expression, it would also have to account for this one, which has more leading spaces. And it would have to account for this one because it's got more trailing spaces. So come up with some code there that will show just how these tokens will get parsed by using the regular expression, not of the token, but of the separator. All right, gang, so I hope this helped kind of outline this week's demo and lab. You've also got a program due, and you've got some question, end of chapter questions to answer. And so good luck on all of that, and we will catch you later.